Hi everybody. Tonight's video is going to be a basic review of graphing equations. We're going to actually do a couple really simple equations, and hopefully this is all review for you. And then the rest of this chapter, we're really going to be talking a little bit more about the different parts of an equation, linear equation, different types of equations or functions, and how those graphs interact. Also, we'll be talking about slope, some other concepts that we've heard of before, but we're going to go a little more in depth on them. But for tonight, it's just going to be a couple simple ones. And when we're going to do these graphing equations, we're going to graph these equations by hand. So what we're going to be doing is we're going to be making a table for each one of these and plotting the values on the graph and then basically connecting the dots. So let's graph the equation y equals negative 2x plus 3. Okay, so generally when I'm graphing equations, I want to set up a table. I usually take my x values, which we'll plug in a second, and then I will evaluate for the y values using the equation, negative 2x plus 3. And then the last thing I want to do is I take those two inputs and I come up with my ordered pairs x, y, which will make up the graph of y equals negative 2x plus 3. Generally speaking, it's a good idea to use the values negative 2, negative 1, 0, 1, and 2, because that gives me a couple points on each side of the y-axis and should give enough, especially with a simple linear equation like this, should give me enough of an idea of how to graph. With a linear equation, you really only need 2 points to graph a line, but we'll use all 5 of these to make sure we're doing everything right. So what we're going to do is just take these values of x and plug them into the equation. So we have negative 2 times negative 2 plus 3. So just make sure we're doing our order of operations right. Negative 2 times negative 2 is positive 4. Positive 4 plus 3 is 7. And we'll keep going. Negative 2 times negative 1 plus 3. That would be positive 2 plus 3. That's 5. Negative 2 times 0 plus 3. Anything times 0 is 0. 0 plus 3 is 3. Negative 2 times 1 plus 3. That would be negative 2 plus 3, so that'll give me positive 1. And then negative 2 times 2 plus 3, that gives me negative 4 plus 3, so that's negative 1. And so now I have ordered pairs. Each one of these points will represent points on our line. So this is the ordered pair, or the point negative 2, 7. Here we have negative 1, 5. Here we have 0, 3. Here we have 1, 1. And here we have 2, negative 1. You could probably actually, most of you will be able to graph this just by looking at this equation using the slope and the intercept. But for now, we're going to get some practice with our algebra for plugging in and evaluating expressions. So make sure that you're making a table that looks all like this. So let's plot our points. Negative 2, 7, 1, 2, 3, 4, 5, 6, 7. That's our first point. Negative 1, 5. 1, 2, 3, 4, 5. 0, 3. 1, 1. And 2, negative 1. So there are the 5 points that are on our line. Now we could draw a line in here if we'd like. Let's make this a nice red line to match the match our points here. And so as long as our line intersects those, then that should be nice and part of follow our equation. So there we go. Here comes the dog. Sorry if you hear any noise in the background. That's my pet beagle, Riley. So that's how you graph that equation, y equals negative 2x plus 3. Simple as that. Make a table, plot the points, connect them with line. Moving on, another example here. when we talk about graphs, sometimes what we'd like to do is identify the intercepts. So the intercepts are where the graph crosses the x or y axis. So the intercepts will be where our graph crosses the x, or you could say intersects, such as intercepts or intercepts the x or y axis, right? So where it intercepts the x-axis is the x-intercept, and where it intersects the y-axis would be the y-intercept. Pretty intuitive. So let's get some more practice graphing, and we'll say graph and find the intercepts of, let's do a quadratic. We'll say y squared, or y equals x squared minus 4. So get a little practice with our squares. So let's make a table. We'll have our x values. Then we'll evaluate for y equals x squared minus 4. Then we'll have our coordinates, and we'll be able to plot our points. So we'll do the same. -2, -1, 0, 1, and 2 are same x values. So now I have -2 squared minus 4. So -2 times -2 is positive 4. 4 minus 4 is 0. -1 squared minus 4. -1 squared is 1. 1 minus 4 is -3. 0 squared minus 4 is 0 minus 4, so that's -4. 1 squared minus 4 is -3. And 2 squared minus 4 is 0. We're going to talk about symmetry later this week, so we'll notice just from looking at this that we are going to experience some symmetry in this graph, but we'll go a little more in depth with that later on. But for now, let's just write down our points and then plot them. So 0, -4, sorry, that's a little sloppy, 1, -3, and 2, 0, right? So I'm noticing that these y coordinates are coming back. So I know I'm going to see some sort of symmetry around that y-axis. But we'll talk a little bit more, like I mentioned. So let's plot these points. -2, 0 is right there. -1, -3 is right there. 0, -4 is there. 1, -3. And 2, 0. Okay, we can't make a parabola with the predetermined shape, so this might be a little sloppy, sorry. So now we're connecting our dots. This is squared, so I knew it would be a parabola in shape, and it's symmetrical along this y-axis, so you could see that it looks the same on each side. But if we want to look at the intercepts, the x-intercept and the y-intercept. So we see that it crosses the x-axis at these 2 points right here. So there's 2 x-intercepts in this case. And then we notice that it crosses the y-axis right here. So there's just 1 y-intercept. So this y-intercept we know is at the point 0, -4. Okay, so that's the y-intercept. And then the x-intercepts are at -2, 0 and 2, 0. So you'll notice something special with these points, that one of the coordinates is always 0. For the x-intercepts, the y-coordinate is always going to be 0. And for the y-intercept, the x-coordinate is going to be 0, right? That y value is the y-intercept, right? So -4 we could say is another way you could identify that as the y-intercept. Okay, so if you're ever asked what are the x and y-intercepts, you can graph your equation by hand, determine where it crosses the x or y axis, or if you have a table set up, you could pretty quickly identify them as the x-intercepts are where y equals 0, so I see that happens in 2 points here. And the y-intercept is where x equals 0, so I see that that happens right here at 0, -4. But sometimes your table isn't going to tell you all the intercepts. That's why it's always a good idea to at least draw the graph or plug it into our calculator, which we'll talk about in class tomorrow. All right, so I hope these were some review examples. We'll do some practice problems in class, and hope you have a great night.